Hey friends, welcome back to the channel. So last time I said we were going to be working on transforms this time. And that's not what's happening. What's happening is I already did transforms and also added time steps and like a minimal scene setup and also like redid some render commands. Like the 2D renderer is pretty much done, minus two things. Those two things being batching and text rendering. And I'm going to do them in that order. I'll explain why here in just a second. But anyway, for this video, I'm just going to go through and show you guys what I've done over like the last week-ish. This is going to be more like a review as opposed to seeing me code with my train of thought and all of that. But I'll try and add some of that stuff in. So anyway, let's just go ahead and hop in real quick. So I had requests to make my font bigger, so I did that. It's kind of a pain because I actually have to, I don't have a keybind in my like terminal set up for changing the font size or anything, and so I have to run a different version of it, but giving it a larger font size. I need to fix that. That's my system is just like that's on brand for me. Anyway, okay, so looking at render, we've got a couple of new primitives that you can see. Texture rendering, that's the other thing that I've got. So we set up the camera last time. Since then, I've set up the transform and textures. I have also added more render commands, and these I will go into in a moment. And then the renderer 2D here, that's weird. Renderer 2D here has a whole lot of stuff going on. And so we're going to go over this. I'm going to save the actual renderer for last. We're going to actually work our way through in the way that I did it. So we're going to hit up transforms first, then we're going to look at the time step and the scene implementation, and then we're going to look at what I did to the renderer and the render commands. But anyway, so first, the reason that I kind of just rushed right through the transform, my plan was to do like the transform and also scenes and just leave it at that for you guys, and that was going to be the next video, because the transform is very similar to the camera in that we're holding locational data. In this case, we're doing position, rotation, and scale. The camera really only has like the position and the rotation. But we've got the transform set up. We have a new function for it that just returns the 0, 0, and 1 functions for three-dimensional vectors respectively. Then we have getters and setters down below, but if you check out this get matrix function, this is very, very similar to the calculate matrices. This does pretty much the same thing, which is to say that we do our translations, we do our rotations. We've added a third step in here, which is scale, and it's important to do your matrix manipulations, transformations in that order, because otherwise things get kind of mixed up. Now with scale, it really doesn't matter that much unless you're doing a non-uniform scale, which technically we are, but it's just scaled to 1. I'm not using it right now. But for translation and rotation, it's actually very obvious, especially if you want to, say you want something to be offset from the origin of your scene, and you also want it to be rotated. Well, you want to rotate it first, and then you slide it over, because all of those manipulations happen around the origin. And so, if you move it over here first, then you rotate, it's going to go around the origin and almost like orbit it, and it's going to end up here. So you want to do those specifically in that order: translation, rotation, scale. That's just for OpenGL. I don't have enough experience with Vulkan or Metal or DirectX to say what they do for their, like, what order things have to be in. And I think that most of that depends on whether it's a column or a row dominant matrix that's being used. We're doing column dominant, which lines up with OpenGL, so everything is just hunky-dory. Anyway, wow, that was a lot of information. I'm kind of out of breath. Okay, so that's most of the transform. There's nothing else in here, I don't think. Yep, just getters and setters. Because I like the idea of all of this information being private. Here, it's defined privately up here because everything is private by default. And I'm a big fan of that, especially for things that eventually, the transform specifically, is going to be moved to like a component. So we're going to have an entity component system. We'll have a transform component that's just basically just going to be holding this struct, and also like the ID of the entity that it's assigned to or something. I don't know. I'm still on the fence on whether I'm going to create or just adopt an entity component system, but I know we are going to have one eventually. Anyway, so yeah, everything's private, so we got the getters and setters, and then that way there's an API established for interacting with the transform without actually providing access to the memory within the transform, is the nice thing. And that's not a huge issue in Rust. That just kind of is a tendency that carries over from other languages. Okay, so now that we've looked at the transform, the next thing I added was a scene implementation. That's kind of baked into the renderer right now. So we're gonna very quickly, I'm just gonna show you the begin scene and end scene functions. Essentially what they are doing though, when you call begin scene, you pass it either the camera or the camera matrix, I don't remember. And then we just have a static mutable scene data. I do a lot of stuff like this in options because it really simplifies having a static thing. And also, if this is a step that has to happen before other steps, you can use it in place of like an isInitialized static boolean. I've done that a lot in C++. Not necessary here because all I need to do is unwrap that option and confirm that it's actually there. If it is, then everything's been initialized, and if it's not, then I exit early because I don't want to screw anything up. So, but essentially the begin scene and end scene are just setting up the scene data. So past the init function, which I'll go over in the renderer section. Here we have begin scene. And essentially what it's doing is we're handing off the camera. We're making sure that our renderer has actually been initialized. So that's what unwrapping this context is. For anyone new to Rust, the if let sum and if let okay patterns are awesome. If you just need to make sure that this thing exists and use it inside of a block, that is my favorite way to do it by far. Just, pro tip, I guess. Anyway, so then we're cloning the camera matrix into the scene data. The reason I say that we're cloning it, I don't think that matrices implement the copy trait. They might. I could check that. Not going to worry about it right now. I'm just going through the extra effort to clone it right now. If at some point I'm profiling the performance and it turns out that cloning is expensive there in the grand scheme of things, then I will stop doing that. But anyway, I want to make sure that while the processing for the renderer eventually, while all of that is going on, that I haven't updated the camera in another thread. So anyway, we got the, let's see. So we get our camera matrix, then we take our shader, we activate the shader, and we set the uniform for the camera matrix, for the projection view matrix. And then we just initialize that scene data variable with sum. Then if we come down here to end scene, we're setting scene data to none, and that's how we know whether or not we're currently rendering in a scene, because we don't want to render outside of a scene for the most part, I don't think. Anyway, and then we have our cleanup function, which is the pair for the init function that I'll show you guys in a second, and it's doing the same thing. Since I mentioned the render context, it's setting that to none, and that's how I'm keeping track of whether or not the renderer itself has been initialized at some point. Let's see. Okay, so let's hop over before we get into the details of what I changed in the renderer. Let's hop over to textures. So this has two parts. First, there is the texture that like implements the OpenGL stuff on the rendering side. But then I also have a text resource here. And so the naming is not fun because these are both textures. I ended up naming this texture data. Excuse me. Because essentially the texture is the unit that is measured or that is handled by OpenGL, at least in the way that I'm framing it. The image or the data from the image is not the texture. The texture is that plus other things, specifically like scaling and mapping functions and things like that. Anyway, so texture data just has the bytes that are in the image and also the width and height. And so I'm going to jump straight to the load direct function because it's doing what I actually want to do. Actually, they both are. Yeah, okay, I thought I had an updated one. Great, and so we're just using the image crate. We're opening the path, we're unwrapping it, and then turning it into RGB8. I want to point out that this unwrap right here, not cool. I don't like that it's there. In my opinion, no like released program should have just a plain unwrap call anywhere in the code. Essentially, I want to try and be absolutely certain that it is impossible for the program to panic. Panics are bad. Panics just kind of the program, and we don't want that. So specifically for this program, but in general for Rust, unless I'm just writing like a quick script to do something where I know that whatever it is I'm unwrapping is going to be there, and I'm absolutely certain of that, which I'm not here, then I generally won't use unwrap. I'm going to add a to-do note here to get rid of the unwrap call. Yep. So yeah. But after that, we're literally just like we're unwrapping it into RGB8. The reason I'm doing this is so that no matter what, I know I have RGB with 8 bytes for each one. And that's just makes my life easier loading it into OpenGL. I love that this is a thing. This is not currently a thing in, like not built in as far as I know to like STB image, which is what I was using in C++. But you could like manually create the functionality to be able to do that. I love that it's baked into the image crate. So yeah, and then I'm literally just giving it the width, height, and the bytes as a vector of unsigned. It's a U8 vector. Anyway, so that's pretty much it for the texture data. Everything else does all the things that it normally does, like we're adding it to the cache if we do load to cache. And that's pretty much it. Yeah, what else have I set up? I think we're just, we got to look at the actual texture, and we're going to look at the renderer, and then that's it. Great. This is... All right, so here is the texture, and so we have the new function here, and this literally, like this is the unsafe function. It loads the data, it does all the OpenGL stuff, and returns a new like texture struct, and that just has the ID in the slot, because currently those are the only things that I need to have. So yeah, then we do... we're just doing general texture loading. Sorry, my brain just right there. Yeah, so we have, we generate a texture, which in OpenGL is just like an ID for the texture. Then we activate it and we bind it. And then we configure the scaling algorithms. We configure how it repeats. We give it the bytes and we generate mipmaps, which for 2D, I guess we really don't need. For 3D, definitely need. But the thing is, this texture works for both 2D and 3D, so we're leaving it in here for now. And then we unbind the texture so that it doesn't get screwed up. Then we return it. I also have an option for new from data. I'll show you why I had that here in just a second, but essentially, instead of giving it a file name, I can just pass it like the bytes directly, or the texture data, like pass it that directly, and it will generate the texture in the exact same way. And then we have the standard like bind, unbind, destroy. The delete textures function is not in the GL crate. I don't know why. Like, it's there. Like, I know it exists in regular OpenGL. I looked at the documentation. Like, I validated that I'm not insane. But it's not in the GL crate. It won't let me put that there. And I am not at all certain why. Anyway, that's pretty much it for OpenGL. That's pretty much it for the texture. Now let's finally just slow down, take our time, go through the renderer. So we've got our scene data and our renderer 2D context. Both of these are handled from the init and the begin scene functions. In the other order, though. So for the scene data, we just have the camera matrix. For the 2D renderer context, we have a VAO, a vertex array for the quad, because quad is pretty much the only thing that we're going to be rendering at the moment. We may eventually, on the 2D side, implement like circles and lines and things like that, but for now, we're just doing quads. If I need to make a circle or a line, then I will do it with a texture, which is like the easy way. It's kind of the cheating way. Nah, it's fine. But anyway, so we've got the vertex array for the quad, we have a shader program, and we have the default texture, which is the cool thing that I did with the new from bytes or new from data function for the transform. We also have our list of quad vertices and our texture coordinates. So these are all good. My texture coordinates are backwards for any people that are looking at this like, that's not right. He says 0, 0 is top left, but it's bottom left. Yes, but my image is upside down. By that I mean traditionally, and I mean I may end up incorrect about this, I don't know. But traditionally, when you import an image, or as far as OpenGL cares, the bottom left corner is 0, the top right is 1, and so that's where your coordinates come from. But when you're loading in an image, or at least I know this is the case with STBI image, and this code works, so I assume this is the case with the image crate, it loads it in upside down. I am not aware of in STBI, there's a function to make it flip it. But I am not certain if that exists or where to find it for the image crate. So this works. I think that's why. I can't say for sure. And then we have our default texture bytes, which is just a single byte of white, which is RGBA. And so I'm literally passing for our default texture, just where is it? Right here. New from bytes, I'm literally just giving it a 4-byte vector of that 1x1 white, and then giving it a width and a height of 1. And that works perfectly. Okay, and then, back up here, we're just setting up our shaders. We have a quad shader. We also are setting up the vertex array with triangle strip. The reason for triangle strip is because it means I don't have to have an index buffer also, which is fucking awesome. You literally just define the first triangle, so we'll do 1, 2, 3, and then you define the next vertex, and it takes the last 2 that you did, so 2, 3, and 4. When you just define this 4th vertex, it draws that second triangle. So that means I save a little bit on how much memory I'm taking up in the GPU when I'm doing this for the 2D renderer, which is great because it is literally only going to be rendering quads. So since that's the case, I know that I'm going to do 0, 1, 2, 3 on every single quad that is coming through. So when I swap to batching, I just put different quads in the array. Every 4 excuse me, every 4 vertices will become a quad. Or will it? I don't know. I guess we're going to find out in the next episode. Okay, cool. So after that, whoopsie. Oh, you know what? Guys, I totally forgot. I made myself a cup of coffee, and I'm not even drinking it. How about that? Okay. That's a little... I mean, you guys have been sitting here with me for 21 minutes. That's a little over-extracted. Ugh. Okay, anyway. So we are binding the vertex array. We're setting up two vertex buffers, one for the vertices and one for the texture coordinates. And this approach, someone actually cued me into this being not traditional. A lot of people will set up what's called an array of structs for their renderer, which is they have a vertex struct, and that vertex struct has a 3-column or 3-item vector 3, for its position, for its rotation, for its scale, for its texture coordinates, for its normals, all of those things. And when you do that, you're setting up in your memory, you have a chunk that is one vertex, a chunk that is the next vertex, a chunk that is the next vertex. And as you add more items through the buffer, you have to jump further and further. And what ends up happening is you are fragmenting your CPU cache when you're doing that. Specifically, and a lot of CPU caches are going to be fine to be able to hold a few of these, quite a few probably, of these vertex structs in the cache. But the problem is that when you're doing your vertex shader, a bunch of that data doesn't matter to your vertex shader. Like, texture coordinates do not matter to your vertex shader, for sure. But they matter later on for the fragment shader. And so when you're bringing that in, what you want to be able to do is say, okay, here are all these positions. And you do all the positions for all of your vertices. And then here are all the texture coordinates. You do all of the texture coordinates for all of your vertices. And that setup, that design is not an array of structs. Instead, it is a struct of arrays. And that's what I'm building here, which is individual buffers that hold the vertices, or that hold the positions, that hold the texture coordinates, that hold the normals, that hold all of those things. We just right now only have vertex positions and texture coordinates, and that's all we're going to need for now? Question mark? Until we start batching. So we're probably going to have to add a few more we're probably going to have to add a few more vertex buffers here in the next video. But anyway, so then we go through and we do the set the vertex count on the VAO. We bind everything. We link the attributes to their layouts in the shader, and then we unbind everything so that nothing gets broken. And then from there, we create the default texture. All of those things go into our render context. We've already gone over begin scene and then end scene and cleanup. We literally have a single function that handles all of the different possibilities for drawing a quad, and I'm very, very happy about it. One sec. So the way that it works is if I want to draw a quad, I just tell it where I want it, how big I want it, and how to draw it. And so I take the position and the size and the rotation. I do my matrix transformations just like with the transform. And then that gets assigned into the shader. I set the quad color in case we want to do a quad that is just a color and doesn't have a texture, or if we want to do a texture and adjust the color values on it. So we have both of those options. We set the quad texture, which up here I'm using unwrap or. This is a great use, a great example of not leaving just plain unwrap in the program. So we're doing unwrap or. So if instead of being none here, or yeah, because I'm passing it in as an option, if the texture parameter is none, then instead we're going to use the default texture. And so if I don't want to render a quad with a texture, I just pass it none for that argument. If I do want to render it with a texture, I pass it the texture. Yeah, so we're setting all of that stuff. We make a single draw call, and then we unbind the texture, and we deactivate the shader. And that's it. Wow, I feel like I've blown through this. I'm very sorry just ahead of time if any of this is like has gone too fast or has been confusing. If so, please, dear God, leave me a comment, tell me. I will make a slower and more detailed video. But anyway, so last thing, I'll just show you guys how we're looking right now. And we're just gonna say cargo run. And boom, it is terrifying. But you can see we're demonstrating a couple of different things here. First of all, textures. Also the different positions, different scales, the rotation, lots of different things. We've got FPS printing out here. It's like jumping, I think it's because I'm recording. It's like jumping back and forth between 160 and 95. But anyway, so we got all that coming through, textures, all of that. I'm really happy with how this has turned out. Like it feels nice and usable. Like if I show you the render thing, like scaffolding that I've got set up for testing all of this shit. It's so simple. I literally just in the init right here, I make sure I initialize the renderer, I set up my camera and the Mandark texture, and I just set all of those things up. And then here, if I here I'm setting the clear color, and I clear, I calculate the matrices on the camera, I update the rotation for what is this for? I think it's for the one that's spinning, just so that I can carry over the value to each subsequent frame. And then I begin the scene. So I've got a commented out block here for rendering. I've got a commented out block here for rendering a bunch of different colored blocks. So we can actually, oh, that is not what I meant to do. We can do that, and we'll comment out that, and then here, if I cargo run, now we'll see a bunch of, it's going to give you a headache, but, and we're actually, it's so much worse like this. Oh man, and we're running so slow. You can see the square here is rotating noticeably slower because of the FPS being so much slower, and that's because everything here is frame based right now. I'm not doing anything with the time steps, not like passing them into the draw function here or anything like that. Although I could, but yeah, okay, so let's just fix that because that's terrible to look at. And then I'm just setting up these quads, and I love the fact that it's just a single draw quad. I provide it the information that I need. That is the best. The reason I say that is because Rust doesn't allow you to overload functions, and so otherwise I would have to do like draw rotated quad, draw quad with texture, draw rotated quad with texture, like... Anyway, yeah, so, and then we just got cleanup functions. That's pretty much it. So yeah, the renderer is, or rather the 2D renderer is almost done. I'm going to be hopefully putting out a video here in the next week. Hopefully putting out a video here soon to go over the batching setup. which hopefully I'm going to be doing with you guys. It should be a pretty simple setup, although I imagine there's going to be a lot of debugging. And so, yeah, that's pretty much all I got for this video. I hope you guys enjoyed it, and I will see you next time. Bye, friends.